These are your 12.3a notes. We're going to start finding the exact trig values of these different angles outside of in the circular trig. And the first day of that is using point trigonometry. So there's a great big long explanation here in the box, but I'm just going to kind of jump in on the key elements there. So we're going to find the trig values, all 6 of them, based on the fact that there's a point, an ordered pair, on the terminal side of the angle. And so what I need to point out here is that when we're figuring out these trig values, we plot the point P, we move over X up and down Y, and that's going to be on our terminal side. So wherever that point lands, our terminal side has to go through that. So then this angle is formed. And so this is the actual angle. Now, that's theta. We're going to actually find the trig values of that particular angle, but we're actually going to use the acute angle inside this new right triangle formed. And the right triangle that's formed is formed by that y value, the x value, and then this new r value that's the hypotenuse, or that's your terminal side. And so we'll figure out all of that information based on that right triangle. So we're going to use right triangle trig. We're going to use this acute angle here that's formed with the x-axis and the terminal side. There's another acute angle up in the air here. I'm going to show you right there that if you write the trig values from that angle, they're all going to be wrong. So you have to understand that the acute angle you're going to use is the one that's formed with the x-axis. And I do want to mention once again that we're finding the trig values of theta. We're just using the acute angle inside the right triangle. Then we can use right triangle trig rules. So when we figure this out, x will be given to us, y will be given to us, and we plot x, y on the coordinate plane. We draw our angle theta based on the fact that P is on our terminal side. And then we draw this nice little reference triangle below it. So we'll drop down y to the x-axis, draw a little reference triangle. We got to find the value of r. R is the distance from the origin to that point. In our right triangle, r represents our hypotenuse. Distance is never negative. So your r value is always going to be positive. Your r value is found by taking the square root of x squared plus y squared. It's actually just using Pythag. If you think about it, you're going to do x squared plus y squared equals r squared. That's your a squared plus b squared equals c squared. But then when you're all said and done, you're going to square root both sides. So to find r is going to be positive because, number one, you're taking the square root of a number. You're squaring 2 numbers. So whether x was positive or x was negative or y was positive, y was negative, when you square them, they all turn positive. So r is always positive because it's a distance. So when we figure this out, now that we have this green reference triangle in here and we're talking about that acute angle in the bottom, the sine of theta, the sine of this great big acute angle, would be the values of opposite over hypotenuse, which would be the ratio y over r. And so we're just filling in this set of notes here. If you're trying to find cosine of theta, again, we're trying to find the cosine of this great big acute angle, but we're going to use obtuse angle. We're going to use the green dot acute angle. That would be adjacent x over hypotenuse r. So what's nice about using the triangle, you just go back to right triangle trigonometry. The tangent of that big theta angle is opposite over adjacent, or y over x. And x just can't be negative because it's in the denominator. That's what they're telling you. Or x can't equal 0. R is never going to equal 0 because it's a distance from 0, 0, so it has to have some length. So this whole x cannot equal 0 thing that they're saying there is just, it can't. This won't work if that's the case. For cosecant is buddies with sine, so you're just going to flip them around. R over y. Again, y can't be 0. secant r over x, and cotangent x over y. So those are the buddies. So you can kind of use sine, cosine, tangent to find cosecant, secant, cotangent. All right, so here are the steps that you're going to follow when you're doing point trigonometry. You're going to draw the angle in standard position and label point P on the terminal side of the angle. You're actually going to label the angle you're finding theta. Then you're going to find r, the hypotenuse, using the Pythagorean theorem, using your x and y coordinates. You're going to find the hypotenuse. You're going to use x, y's, and r values to evaluate the trig function. You're also going to use that acute angle of the triangle. And just one last time, we are finding the trig functions for theta, but we are using the acute angle with the x-axis. So let's go ahead and try this. We're going to find the exact values. Exact means no decimals. If there's a radical, you got to leave it in radical form. So everything will be exact. And so this is our first order pair. That's actually 8 comma negative 15. So if I'm going over 8 and down 15, I'm going to be in the fourth quadrant. It doesn't have to be to scale. Okay, and so I'm going to draw my angle. There's my initial side. There's my terminal side, and here's point P. I'm going to label that this is angle theta. So we're going to find the 6 trig values of that angle. Okay, we've never done that. And so when we're finding the 6 trig values of that angle, we're actually going to use this little tiny angle inside, formed with the terminal side and the x-axis. So to do that, I need to make a right triangle. And I went over 8, and I went down 15. So I know it's a little different than any other triangle in geometry. We wouldn't allow for a side measurement of a triangle to be negative 15. In this case, the negative is telling us that we went down 15 units rather than up 15 units. So we're going to use that negative when we're writing our trig values. It tells us where that angle is located. So we got to find our r value. So 8 squared plus negative 15 squared is equal to r squared. 64 plus 225 is equal to r squared. And that is going to give us 289 is our r squared. And when we take the square root of that, I believe that is 17. The square root of 289 is 17. And so r is equal to a positive 17. So when you square a negative 15, it becomes a positive number. And so everything's positive. You take the square root, everything's going to be positive. So I'm just going to label 17 over here in my picture. And now I have all 3 dimensions of my triangle. We're going to go through and just write the 6 trig values. So the sine of theta, that great big angle, is equal to the opposite of that little acute angle, negative 15, over hypotenuse 17. Cosine theta is adjacent 8 over hypotenuse 17. And tangent theta is just opposite, negative 15 over adjacent 8. Cosecant theta is just the same 2 numbers as sine, but just in reverse order. So since it was negative, this one's also negative. I just put the negative at the top. Secant theta is 17/8, and cotangent theta is negative 8/15. I always simplify those if we can. They're in simplest form. All right. I'm going to skip number 2 because number 2 is just like right triangle trigonometry. It's right in the first quadrant, so nothing's really going to change. Let's go to number 3 really quick. So for number 3, negative 10 and positive 8 tells me I'm going to the 10 left, and I'm going up 8. And so I'm making my point, draw my angle, and label my information. So I'm going to label angle theta. We're going to just assume that these are always positive thetas. Okay, we could have rotated around the other way, but let's make them positive angles. And then we're going to draw our right triangle. dropping down from that point, making it a right angle. I went to the left 10 units, so that's why it's negative 10. I went up 8, and I got to find my R value. I'm going to use this little acute angle formed with the x-axis in my terminal side to write my trig values. So 8 squared plus negative 10 squared is equal to R squared. That's 64 plus 100 is equal to R squared, 164. Now when I take the square root of 164, it is not perfect, but I recognize that 4 goes into it 41 times. So I'm going to break this into a perfect 4 and 41. And we get 2 root 41 for our R value. Now it's not pretty. It's going to get a little ugly, but it's good to show you one of these. So to write our trig values, the sine of theta is equal to opposite 8 over 2 root 41. That's my hypotenuse. Now the 8 and the 2 can divide. 8 divided by 2 is 4. So now I have 4 over root 41, and you can't leave it that way, so we need to clean this up. The good news is if I clean up sine, cosecant, I should not have to clean up. So just keep that in mind, that if you clean up 1, you shouldn't have to clean up its buddy. And the square root of 41 times the square root of 41 becomes the square root of 41 squared, which is 41. So this is our sine value right here. Cosine is also going to be ugly. Cosine is going to be adjacent negative 10 over hypotenuse 2 root 41. The negative 10 and 2 simplify to negative 5 over root 41. Do the same thing, rationalize the denominator. If you can do that step in your head, I don't need to see the times 41 times 41 as long as you do it. So you get negative 5 root 41 all over 41. So we had to show a lot of work for cosine, but that means that when we do cosecant or secant, we won't have to do all that work. Tangent should be easy because we're not using that ugly number. Tangent is opposite 8 over adjacent negative 10. Still needs to be cleaned up. I can take a 2 out of each, and so it becomes negative 4/5. So tangent is negative 4/5. Let's go ahead and do cotangent really quick because it's an easy one. Negative 5/4. And then I want you to look at cosecant and secant. So I just ran out of room to the right, so I'm just going to put them underneath it. If sine is equal to 4 root 41 over 41, if I flip that, the radical's in the denominator because we worked hard to put it in the numerator. So I'm actually going to find one along the line that's a little bit better. I could use this one, but that 8 and 2 isn't simplified. So go back to this step. That's the one we want. That's the one we want to flip. Square root of 41 over 4. They're all equivalent forms. All 3 of those sine values are the same, just the simplified form is the last one. So go back through, look back through the line. You shouldn't have to show work because otherwise you're going to have to show a bunch of work again. Secant, same thing. We showed a bunch of work simplifying in cosine, so we shouldn't have to show any work for secant. Use this value of secant, cosine. So we're going to go square root of 41 or negative square root of 41 over 5. I always put the negative on top. All right, there's point trigonometry. The other thing they do in this chapter is they give you one of the 6 trig values. They ask you to find the remaining 5 trig values. So you're going to do the same thing we did before. We're going to draw a picture, and we just have to break it down. So in this particular case, they're giving us the fact that cosecant of theta is negative 5 over 3. Well, cosecant, if you remember, is the buddy with sine, so it's the hypotenuse over the opposite. So I'm looking at the hypotenuse and I'm looking at the opposite. So if it's negative, the hypotenuse can never be negative. So even though it says negative 5/3, the hypotenuse has to be positive 5. So that means my side opposite is negative 3. So when I go to draw this, it's telling me that it's in quadrant 3. So that's another reason why I knew that the side opposite was -3. That's how we get into quadrant 3. So this is quadrant 1, this is quadrant 2, and this is quadrant 3. I need to be in this quadrant. So when I draw this picture, okay, I'm going to draw my angle, and I'm just going to make sure it's down here. I really don't care about the size. This is angle theta that we're finding the trig values of, but we're going to use point trigonometry and make a point right here. And we're going to use this acute angle, again, the one formed with the x-axis, not the y-axis. And so they're giving me that the side opposite that little tiny angle is -3, so that tells me I went down 3. My r value, or hypotenuse, is 5, so I need to find my x value. Now when I find my x value, I'm going to use the Pythagorean theorem. It's going to give me a positive value, but because I shifted to the left, I'm going to force the sign. So I know it's a negative something. So I'm going to do -3 squared plus x squared is equal to 5 squared. 9 plus x squared is equal to 25. I'm going to subtract 9 from both sides, and x squared is equal to 16. When I take the square root of that, x is equal to 4. So my x value tells me I shifted 4 to the left. So notice when I set up my Pythagorean theorem, we weren't looking for the hypotenuse. We had the hypotenuse, we had a leg, we were looking for the x leg. And now we just go through and find the rest of the trig values. So there's going to be 5 of them. Sine of theta is opposite -3 over hypotenuse 5. I actually could have found that just from the given information right here. But now we have it for all the other ones. Cosecant they gave us. Cosine theta is adjacent -4 over hypotenuse 5. Tangent theta is opposite -3 over adjacent -4, which becomes a positive 3/4. When you have a negative divided by a negative, it's positive. Cosecant we have. Secant theta is -5/4, and cotangent theta is positive 4/3. And so you just have 5 answers instead of 6. That's it. So could you please tell me why the r value is always positive? And I want you to find just the sine value of an angle formed with the terminal side with point P on it, -3, -4. I want to see your picture. I want to see you label theta. I want you to go through, but you don't have to find all 6. You only have to find the sine value. So you have to find r and all of that information. Good luck.